In this video, we're going to be looking at what we call the first derivative test. So basically with our first derivative test, we are using our first derivative of the function that we have. In this instance, we are given our f of x, which is minus 6x to the exponent 4 plus your 80x to the exponent 3 minus 300x squared plus 20. You see? So first things first, we have to find the first derivative. After finding the first derivative, we equate the first derivative to 0 in order to find the critical points. After finding the critical points, we're gonna go to our number line and we check what we call the local extremes. See, so our local extremes, they just want you to tell them where do we have your local maximum or your local minimum. So if you perhaps you have a graph and you have something that looks like this, then you know definitely this one that can be your local max, then this one would be your local minimum. You see, so basically such things that they want from you. So without wasting of time, let's start by finding the first derivative for this one. So what would be the first derivative? First derivative, it would be, we're going to have minus 24x to the exponent 3 plus this one is going to give us 240 x squared minus our 600x, and the derivative of 20 remains 20. So now, as I said, we're now going to equate this to 0 and find our critical values. So we'll say we have minus 24x cubed plus 240 x squared minus 600x is equals to 0. So we have to try and find the factors for that. So since we have x throughout, it means to be safe, if we're also considering this values 24, 240, 600, they all share a common factor, which is 24, meaning we can divide by 24 throughout. But since we are also having x on each and every of those, it means now we can actually just take minus 24x outside, so that we can be left with a positive x squared inside. So we're going to say we have minus 24x into x squared. The reason why I said I'm taking a negative is that I want to be left with a positive. You see? So we're going to have here the sign is going to change. It's going to be negative, because a negative, remember, if we're multiplying this backward, it should be able to give us whatever that we had here. So you just have to be careful with that one. Then your 240 divided by 12, this gives us our 10. Then we're going to have that 10x. Then the 600 divided by 24, it gives us 25. But now the sign is just going to be positive. Then we have that 25. Then this is equals to 0. You see? So this one, if you can notice, this is basically your, let me see. Oh yeah, your x minus 5 all squared. So we can basically write this one minus 24x, and this can be written as your x minus 5 all squared. This would be equals to 0. Still, even if you were to factor out this one, you would still get to the same answer, because I know we use different methods of trying to find the factors, then by conclusion you will say your x would be 0 or your x would be equals to 5. So now since we are done with that one, we're going to go to our number line. That we have our number line that's like this. Then what are the critical values that we got? These were the critical values. Our critical values is 0 and 5. We're having that 0 and 5. And remember, where are we testing? We're testing in the first derivative. So each and every time you're required to do your test, you test in your first derivative. You don't test in the original. When you're inputting these values into your original, it means now you're trying to find your y values, and which is incorrect. So what you're going to do is that you're going to look for any number between this 0 and to your left hand side. It could be -1 up to -infinity. Then you input it into this one and check the sign convention. Remember, here I'm working with my first derivative, so that's why I'm just basically writing the signs as you see them like this, showing that I'm still working. So let's suppose you put a negative, or you use a -1 and you input it into this one. So here you are going to get a positive answer. Then between, you use any number between 0 and 5 and you input it here, and here you are going to get a negative answer. Then you use any number that's here. It could be 6 up to positive infinity. Then this side you get, I think it's negative. That's your negative. So now what are we required to do? So now we're required to explain the local extremes. So how I do this question is that, okay, now that you're done with this, I normally just write dotted lines like this. So I would interpret it like this, that exactly at this point your 0 and your 5, that okay, what is happening on either side. So when I was coming this side, it was positive, it was increasing. So you can say you have something that looks like this. Then when it got to this side, it started decreasing, or it was negative. Then you write something that looks like that. You see? So definitely this one, it tells you that at this point you're going to be having your local max, because this one, they just want your local mean and also your local max. You see? So now, but we come to this part. This part is negative. So how is negative looking like? A negative would be something that looks like this. And even this side, we still have a negative. Just to make sure, is it negative? It's just I don't have a calculator, but I just hope it's negative. So I'm just wanna give I wanted to give an example where we would have if it happened that this side, it was positive, it was going to be something that looks like this. You see here, it was gonna mean that at this point we have a local minimum, because if we have something like that looks like this is a local max. Then if it's looking like this is a local minimum. But now we have two arrows that are showing signs of decreasing. So each and every time you come a question where you are having negative and negative, and like you are not having something that's concave down or concave up, just know that exactly at this point here, this is where you are going to be having your inflection point. So this, your inflection point, is normally where your graph is going to change its shape. So to find out more about this, if it's an inflection point, you can actually go again and find the derivative of this, meaning now you are going to be looking at what? At your second derivative. If you find your second derivative, you'll find that one of the critical points or your x values is going to be 5, and that will indeed confirm the saying that this, it's where the graph is going to be changing shape. But now, since we are not working with the first derivative, with the second derivative, we're just going to leave it there. We're just going to leave it there. So now we have to do our conclusion. We will say f has a local maximum at x is equals to 0. Then you have to come again and say the sorry about that, the local maximum, is f of 0 is equals to, then you input this 0 that you got into the first equation, not the derived one, then this one will just going to give you 20. Because there's also a way that they like to trick the students. There is a question that they can ask in your MCQs where they're asking you about the local maximum. This is your, I think they call it what is the local maximum value of this function. So when they're talking about the value, this is when you're going to input this local max that you got here at your x-axis and input it into this function in order to be able to find your local value. So let's just say this one will be your local, we'll just say local max value. When you see the word value, it means now you have to take this one, the maximum value that you got at your x, and input it to find this one that they're looking for. So now you're going to come again and say f has no local extreme at x is equals to 5. So as I've explained, that this is actually your inflection point, and that's basically how you do this question. So the last thing that I want us to talk about is this table that I'm going to draw for you here. So each and every time you are doing these types of questions, always keep this in your head. You have your first derivative, then you have your second derivative. So how in calculus are these questions going to come to you when they're asking it in the form of MCQ or your long form questions? So you can be asked to determine your critical points. They give you a quick function in your MCQ, then they tell you to find your critical points. You find your critical points by doing your first derivative. See, after doing your first derivative, you'll be able to find your critical points. Then when it comes to this side, they might tell you to find the inflection point. So when they tell you to find the inflection point, that's when you're going to use the second derivative in that function that you have. So in which instance again would you be required to use your first derivative? It will be when they ask you to tell them where the graph is either increasing or decreasing. You see? So now when it comes to this side, they might give you a function and they ask you some questions about concavity. So something like you tell us where the graph is concave up or concave down. So in here again, you can have a question, or in MCQ, in MCQ or the long form questions where they ask you to determine your local extremes. You see? So yeah, I just hope I've covered them all. Then also here, that would be the first derivative test. Then this is when you are having your second derivative test. See, so these ones I can say they are applicable in MCQ, so I'm just gonna write it in MCQ also. MCQ, this one are also applicable in MCQ, so you just have to be careful. So the local extremes I've seen sometimes they also ask it in your MCQ. Your first derivative test and your increasing or decreasing, it's normally in your long form questions because you have to use the number line, you see. So that's basically the table that summarizes this chapter. So yeah, if you found this helpful, please like the video and consider subscribing to the channel. See you in the next video.